Define the term force. Force is a push or pull. A force is not something that an object contains or has in it. A force is exerted on one object by another. We say that force is a push or pull. Force is not something that an object have or has in it. So we're gonna look at this rubber band here, and also we will look at the t-shirt. So I will measure out a piece of this t-shirt and a piece of the rubber band. So we will measure the rubber band in inches. So far it is 4 inches. Oh, it's so hard for you to see. 4 inches. Anyhow, I will then also measure 4 inches on the t-shirt without pulling it. Just measure it as normal. Good. Now I will pull as hard as I can. I will pull. Also, while pulling, I will also measure this. So let me see. So we have here, the first one we had 4 inches. So when I pull strongly, I have 5.5 inches. That's for the t-shirt or the jersey. Now let's see for the rubber band. So the rubber band actually, we can say 13 because it's just a little bit from 12. So we will say 13 inches. Now when you look at that, the first thing you would notice is that I am pulling, and we said that force is a push or pull, but in this experiment here we are actually pulling something. We're using our strength to pull an object. Why when we pulling on objects it do not return to its original size? Now look at this here. I'm using a very small rubber band. So in this rubber band, when we pull, it stretches, right? We're using force to pull something. We pull it, and you would notice here that it will go back to its same size. But if we pull a bit stronger, oops, see what happened there? It will eventually burst or destroy. So it will not go back to its original form because this is not how this is not what we started with. So yes, oh, it actually stretches, but it did not go back to the same size. It is actually done with. But on the other hand, with the jersey, we said 4 somewhere around here. So we keep stretching. It didn't burst. It actually went back to the same size. But after stretching something over and over, it will eventually lose its elasticity. So now in this presentation here, we would normally get away with the idea that, oh, elasticity is something to do with rubber. And I think personally we confuse ourselves with elasticity and flexibility. This here is flexible. It's flexible. Now let me explain something. So let's say a rubber band, and let's say a spring. Now the spring, okay, let's just make it look like a spring. So spring is something looking like a little, wrong shape, like wrong. So that's what a spring is. So the spring is actually something like this. So now the spring would actually, when we pull or we push, it deform the shape, right? So, but it will quickly go back to its shape as we pull it. I'm talking about the spring. I'm not talking about the rubber band. I'm just using an example here. It will quickly go back to its size. As for the rubber band, it stretches more, and it wouldn't go back to its size right away. It take a bit, some time. However, the reason why it will go back to its shaped right away with the spring is because there is there's more resistance. There's more resistance. Unlike the rubber band, there's less resistance. So it's easier. It's easy to stretch. So now the question is, which one would you say is more elasticity or has more elasticity? You would more want to say the rubber band, right? But no, actually, it is not the rubber band. It is more the spring that we said. It look, we're just using this as an example. It's more of the spring that is more elastic. It has more elasticity because it jumped back to its normal shape or size.